Hello students, welcome to the 12th video lecture of Digital System Design subject. Today we will learn about state diagram of JK flip-flop. Here is the state table and truth table of JK flip-flop. With the help of state table, we can form K-map, and with this, finally we can generate the characteristics equation for JK flip-flop. Also, with the help of state table, we can make state diagram. So let's start with truth table. Truth table of JK flip-flop is generated with the help of internal diagram of JK flip-flop, which may be constructed with the help of NAND gate or NOR gate. So here is the truth table for JK flip-flop. Let's begin with this truth table. As you can see, if the value of two inputs J and K is 0, then the output should be no change. If the value of JK is 0, 1, then the output should be reset or 0. If the value of J and K is 1, 0, then the output should be set to 1. If the value of JK is 1, 1, then the output should be toggle. That means if the previous output was 0, then next output will be 1. If the previous output was 1, then the next output will be 0. We will use this principle in forming the state table. So here, as you can see, the state table is the combination of present state represented by Qn, next state represented by Qn plus 1, and two inputs J and K. So here, as you can see, that if the value of J and K both are 0, so in that case, as you can understand, with the help of truth table, if the value of J and K is 0, that means the output should be no change. So obviously here we are getting the output no change. That means Qn was 0 and also Qn plus 1, which is the next state, will also be 0. The next case, as you can see, the J and K values are 0, 1. So as per truth table, as you can see, if the value of J and K are 0, 1, then the output should be reset. Doesn't matter what was the previous output. So here, as you can see, if the value of J and K is 0, 1, that means the output will be reset. That means it was previously 0. So now the next output will also be 0. For the next case, if the value of J and K are 1, 0, in this case, from the truth table, as you can understand, if the value of J and K are 1, 0, then the output should be set. If suppose the previous output was 0, then the next output will be 1. The next case, when the value of J and K are 1, 1, that means the output should be toggle. Means if the previous output was 0, then the next output will be 1. Also, there are another cases when the value of J and K are 0, 0, that means no change. So as you can see, Qn is 1 and Qn plus 1 will also be 1. In case of J and K 0, 1, that means the output will be reset. So final output as Qn plus 1 is 0. If the value of J and K is 1, 0, that means the final output will be, in this case, set. It was previously 1, so it will remain at 1. Now if the value of J and K are 1, 1, that means the output will get toggle 1 to 0. So this is the concept which we need to understand. Okay, with this concept, now as you can see, here again we are using the same state table. With the help of this state table, we will form the K-map. So here we need to understand these columns carefully, Qn and J and K. So these are the columns. With the help of these columns, we can understand how the K-map is going to be formed. So as you can see here, I'm repeating my words. You need to understand column Qn, then column J, then column K. So as you can see, in column Qn, the first value is Q, first value is 0. Then in column J, the first value is 0. Then in column K, the first value is 0. That means 0, 0, 0. So decimal equivalent is 0. Similarly, for next value 0, 0, 1, the decimal equivalent will be 1. For next value 0, 1, 0, the next decimal equivalent will be 2, right? And also for 0, 1, 1, the decimal equivalent will be 3. Then for 1, 0, 0, the decimal equivalent is 4. Then for 1, 0, 1, the decimal equivalent is 5. Then for 1, 1, 0, the decimal equivalent is 6. And the last one, 1, 1, 1, decimal equivalent is 7. So this decimal equivalent we need to understand. Why? Because while putting the values in the K-map, you need to understand where is the position. So let me tell you again. As far as K-map is concerned, this is position number 0, this is position number 1, this is position number 2, this is position number 3, this is 4, this is 5, this is 6, and this is 7th position. So according to the position, we need to put values of Qn plus 1 from this column. As you can see, at position number 0, we are having value 0. So 0. At position number 1, we are having value 0. So 0. At position number 2, we are having value 1. So 1. At position number 3, we are having value 1. So 1. At position number 4, we are having value 1. So 1. At position number 5, we are having 0. So 0. At position number 6, we are having 1. So 1. At position number 7, we are having 0. So 0. So this is the concept by which we can put various values at K-map. Now, after that, we need to make the pairs or singles with the help of K-map. So as you can see in the K-map, so this is the pair. For this pair, if you move in left hand direction, you will find Qn bar, and if you move in top direction, so you will find the common value, that is J. That's why we are writing J, Q, and bar. For the second value, this one and this one. So for these two value, from the left hand side you will find Qn, and for these two single values from the top hand side you will find K bar. So you will write K bar Qn. Now finally, Qn plus 1 is equivalent to JQ bar plus K bar Q. That means this is the characteristics equation of JK flip-flop. And also with the help of a state table, we can form the state diagram. So here is the state diagram. As you can see that the values are moving. See, these are the states. This is 0 state, this is 1's state, right? So Qn, if the values are moving in a similar pattern, that means values are moving from 0 to 0, that means we will use this particular arrow. If the values are moving in this way, 1 to 1, that means we will use this particular arrow, right? So this is the concept which we need to remember. And also one thing which we need to understand, if I am writing 0, 0 by 0, that means the numerator part 0, 0 is belonging to inputs JK, and denominator part 0 is belonging to output Qn plus 1, right? So with this we can form state diagram. As you can see that the values are moving from 0 to 1. So as you can see, the values are moving from 0 to 1. Output was 0, Qn was 0, now Qn plus 1 is 1. For this, the inputs are 1, 0 and the output is 1. So the inputs are 1, 0 and the output is 1. Also with this case we are having 0 to 1. but the inputs are 1 1, output is 1. Inputs are 1 1, output is 1. So with this phenomena we can understand the concept of state diagram. Thank you.